If you're watching this video, I'm assuming that you are on Mac OS X and that you are trying to install FFmpeg. If you're on Windows right now, feel free to skip on to the next video where I've laid out some directions on installing FFmpeg if you're on Windows. So again, only stick around if you're on OS X. Okay, hopefully all the Windows guys are gone at this point. I gotta tell you, installing FFmpeg is probably about an order of magnitude easier on OS X than Windows. So you and I right now, yeah, we got a pretty sweet thing going because it's much easier to get through this installation process. So let's get to it. The first thing we're going to do is just to make sure that you have Homebrew installed on your operating system. Homebrew is a package manager for OS X. We can use it to install a lot of different types of software. To make sure that you have Homebrew installed, you can write out the command which brew at the terminal. If you see something that looks like this, a path right here, then you're good to go. But if you see a message that says something like cannot find brew or something like that, then that means that you need to install Homebrew. To install Homebrew, it's really simple, really straightforward. Inside your browser, you'll go to brew.sh. And then once here, you'll find this big link. Just copy the entire thing, go back over to your terminal, paste the link, and hit enter. It should take just a minute or two to actually install Brew, so it should be pretty quick. Now, assuming that you have Brew installed, or assuming that you just went through the installation process, you can then install FFmpeg by writing brew install FFmpeg. And that's pretty much it. It's going to take Brew a couple minutes to actually go through the installation process, but in general, it's just a kind of one-shot deal. You just got to run that command and you'll be good to go. Once Brew is all done with the installation process, you can then confirm that it was updated or installed successfully by opening a new terminal window and writing out which FFmpeg, like so. And you should see, again, a path appear on the screen. If you don't see a path here, if you see something like, hey, cannot find file FFmpeg or something like that, that means that there might have been something wrong that went, or something might have went incorrectly or went wrong with the Brew installation. So feel free to post in the forums or send me a direct message and just say, hey, I'm having trouble getting this installed. Can you help me out? Okay, so that's pretty much it for installation of FFmpeg on OS X. Again, you just want to be at the point right now where you can type out which FFmpeg like so and see a path appear on the screen. Okay, let's continue. Be sure to skip over the Windows installation video in the next section. Go to the one after that and we'll talk about how to actually make use of FFmpeg inside of our application. In the last section, we started talking about the first application that we're going to be working on. Remember, we're going to make a tiny utility where a user can select a video file and then click a button to get the total length of that video file. So yep, we'll be pretty straightforward, but again, we're going to learn a ton about Electron along the way. So without any further ado, let's get started on our project. I'm going to change over to my directory, and my terminal, and I'm going to make a new project directory to house all the code for this project. So I'll run make directory, and I'll call this new project about video info. Then I'll change into that directory. Now, whenever we kick off a brand new Electron project, we're usually going to want to install a couple of different dependencies that are going to help us build the project. To record all these different dependencies that we install, we are going to create a package.json file. A package.json file is used to record all the different dependencies that our project relies upon. We can automatically generate a package.json file by running the command npm init. When we run npm init, like so, we'll then get prompted with a couple of different questions that we can fill out to describe a little bit more about the purpose of our project. Now for right now, I don't really care about any of the entries here, so I'm just going to press enter to get through all of them. And then when I get prompted with, hey, is this okay? Yep, that looks totally fine to me. We'll hit enter one more time. So if I now look inside of my project directory, I've got just one file, the package.json file. We're now going to use this package.json file to install exactly one dependency to our project, and that is, as you might guess, Electron. So we're going to install Electron as a dependency to our project by running npm install --save Electron. This will reach out to the NPM registry and grab a bunch of different files related to Electron and allow us to kickstart or start off a Electron project on our system. So it should only take a second to install. Maybe that'll be enough. Yep, looks good. So after that installation is complete, I'll then open up my code editor and we'll take a look at some of the different files that we're going to need to create inside of our project. So remember that we're going to have two separate files inside of this project. We're going to have first the JavaScript file that's responsible for starting up the Electron application and the main window. And then we'll have a second file called the index.html document, which will be responsible for showing some actual content to the user. For this first application, that's really all it's going to take, just the two separate files. Let's open up a new file, a new JavaScript file, inside of our root project directory. I'm going to call this index.js, like so. So this is going to be the one JavaScript file that we have. We'll use this to first create our Electron application and then generate that brand new browser window. I want to talk to you a little bit about the environment that we're writing code in here. So when we create this index.js file, it will be executed by the Electron runtime inside of our terminal environment. So inside of this index.js file, we can use any type of code that we're used to whenever we are writing a node type project, so a node.js project. By that, I mean that we can use some really familiar syntax like, say, require to require in different modules. So the first thing that we'll do is require in the Electron library by using the require syntax. Now, if you're used to writing React code or maybe even Angular, you might be used to writing import statements using the import keyword, something like import Electron from Electron. So this might look a little bit more familiar to you if you're coming from front-end development. Because the code that we're executing here is running in the node.js runtime, the Node.js runtime makes use of common JS modules, which make use of the require syntax. Node.js does not yet have support for ES6 modules, and ES6 modules are what use the import syntax down here. So just to be clear, throughout this whole course, we're usually not going to be using the import syntax anywhere whenever we are writing Electron-specific code, just because it is not yet supported by Node.js. Cool. Okay, so this looks like a good start. Let's take a quick break, and then we're going to come back and talk a little bit more about this Electron library and what we can use it to do inside of our project. So I'll see you in just a second. Now that we've finished up our first application, let's do a wrap up of everything that we covered. The first thing we covered was that when we create an Electron application, we're really creating two separate locations where our code is being executed. The first is the overarching Electron app, and then the second is any browser window that we spawn to support our application with some place to show some content. By default, Electron creates the overarching Electron app for us. We can get a handle on that app by referencing the electron.app property from the require statement from Electron. The actual main window or the browser window is something that we create ourselves at some point during the application's lifecycle. In this case, we waited for the application to hit the ready state, or the state to say, hey, ready for executing some code or doing something with the app. When that occurred, we then created a brand new browser window and assigned it to the main window variable. We then loaded up an index.html document directly into that window, which made some content appear on the screen. The next big thing that we covered was the use of the IPC system. So with the IPC system, let me pull up the diagram. We've got quite a bit of them. Okay, here we go. So the IPC system is used to communicate between different running processes inside of our Electron app. Remember, the Electron app side of things, the thing that we were just talking about, is a completely separate running process on your machine, totally decoupled from the main window or the browser window that we created. In order to communicate between these two different processes, we have to set up IPC communications, or inter-process communications. The IPC system is event-based. So on one side, we will send or trigger or emit an event, and then listen for it on the other side of the application. One awkward thing about the IPC system was how all the different event handlers were named. So on the browser window side, in both cases for receiving and sending and receiving events, we referenced the IPC render object. But on the Electron app, we instead referenced IPC main to receive an event, and then we referenced the browser window's web contents to send an event back over. Again, I do recommend that you either jot down a couple notes about this diagram or take a screenshot of it so you can refer back to it in the future, because this is a really easy place to slip up as far as IPC goes. So I'm definitely leaving off a couple of other things that we covered, but I think those two are the biggest topics I want to discuss for this application. Now that we've finished up this app, let's continue in the next section where we're going to start working on our next project and dial up the difficulty just a little bit. So I'll see you there. In the last section, we added in a query selector to find the input element and then read some details about the file that the user had selected. So we now know the path, the name, the size, and the last modified date of the video file. But very critically, we don't actually know the duration of the video file. So we need to use some kind of tool or some methodology to read the duration of the actual file. So this is where things are going to start to get really interesting. It's going to be a lot of fun on the Electron side of this application. So let's talk about how we're going to solve this problem. To get some more details about the actual video file, we're going to make use of a command line tool called ffmpeg. ffmpeg is a colossally popular command line tool that is used to work with video and audio files. ffmpeg works behind the scenes on a lot of different very popular video editor software or pieces of software out there already. So this is quite a well-developed and quite a famous little piece of software. The ffmpeg library does many different things, like unbelievable number of different things. It can convert video files, it can merge video files, it can merge audio and video tracks, it can do just about anything you could possibly imagine to a video file. One of its very small purposes, or one of the very small things you can do with it, is use it to query for the duration of a video file. And so that's what we're going to do. We're going to install this ffmpeg module, or command line tool, and then we'll use it to query for some details about the particular video file that the user selected. So we're going to install the ffmpeg module. We're also going to install another module called ffmpeg fluent. A little bit more about the relation between these two modules, or these two libraries right here. ffmpeg is a standalone command line tool, and it's intended not only for developers like you and me, but also video editing professionals, or just about anyone you could possibly imagine. So it's not really something that was made with Node.js or Electron or JavaScript developers in mind. It's just a very general purpose tool. To give us a nice way or a nice API around this command line interface, we're going to make use of a module called ffmpeg fluent. Fluent is a module that just makes working with ffmpeg easier from Node.js or from Electron as we are using it. So first is ffmpeg, which is doing the actual video file reading process. Fluent right here is just a wrapper around it that's going to make our lives a lot easier for interacting with it. Okay, so that's a little bit more about the two modules that we're going to have to install here. I want to first spend a little bit of time just to look up some documentation around ffmpeg, and then we'll take a break and go through the installation of the ffmpeg CLI. The installation process is slightly different on OS X versus Windows, and so I'm going to break out into two separate videos where you'll go through the video that matches up to your operating system so you can get the correct version installed. Okay, so again, let's look at the documentation for ffmpeg fluent and get a better idea of how it works. Inside my browser, I'm going to navigate to npmjs.com, and then inside the search bar at the top, we'll do a search for ffmpeg fluent. And I think I got the order wrong. It's actually fluent ffmpeg, my mistake. Okay, so once here, if you wish, you can certainly pause the video right now and check out some of the documentation on this module. The actual command that we're going to use is called ffprobe. So we're going to call ffprobe, and let's see if we can find any of the actual documentation around it. Here we go. Okay, so down here, this is what we really care about. So what we really want to do is read some metadata about the file. Metadata is data about a particular file that is not necessarily related to the file's contents, but more descriptors of the actual file. So like the file name, file path, very importantly, the file duration. So we can use this ffprobe command to read some details about the file that the user selected and get back some information on that particular file. So in practice, all we have to do is get the Fluent FFmpeg module installed. We'll call this ffprobe function and pass in the file to the video that the user selected. And we definitely have that file path right there. We had just seen it inside our browser console just a minute ago. So essentially, all we have to do is call this function, pass in the path to the file, and then we'll add in a callback function that will receive some of the data or receive some metadata about that particular video file. Okay, so looks like we definitely have some work cut out for us. FFmpeg on itself is a little bit confusing, but we're also going to kind of further complicate things by adding in some Electron related concepts. We're going to get to that in just a little bit, but for right now, I want to focus on just getting these two modules installed. So right now, inside this section, we'll first install Fluent FFmpeg, and then we'll take a break, and then we'll install FFmpeg by itself, just the command line tools, in the next section, which will be corresponding to your particular operating system. So let's change over to our terminal, and we will install that Fluent FFmpeg module by using npm. So we'll npm install -- save Fluent FFmpeg, like so. Okay, so this should just take a moment right here. We'll let it finish up. Very good. Now, again, we're going to take a quick break, and then we're going to continue in the next two videos. Find the video that corresponds to your operating system, and we're going to walk through the installation process of the FFmpeg CLI. So, see you in just a second. In the last section, we covered a lot of different topics. We first started off by pulling the app property off of the Electron library. Remember that this app property right here represents the underlying process that's executing our code. We interact with this app object right here by using event-based programming. So over time, the app object will start to emit different events, the first one being when it starts to get ready to execute some amount of code. So we listened for the ready event, and when the app was ready, we then console log something. This index.js file is executed inside of our terminal. And so it's really important to note that when we start up our actual project by running npm run electron right here, any console logs or any debug information that we put into that index.js file is going to appear in this terminal right here. Now, when we start to spawn some different browser windows and we start to do some console logs inside of those browser windows, the log statements that we add in are going to appear in those respective browser windows. But we'll see that in action in just a minute. Okay, so I'm going to stop my running process and go back over to my code editor. I'm going to take out the console log that we have in here right now, and I want to start to think about exactly how we're going to create a new browser window, which we're referring to as the main window, to show some content to the user. So let's get to it. To create a new browser window to show some content to the user, we'll pull another property off of the Electron object. That property is called browser window. We can create a new browser window inside of the app.onReady event handler down here by saying new browser window. And then we'll pass it an empty object. The empty object right here, we can eventually start to add in some configuration options, but for right now we don't have any configuration that we need to pass to it. So we're just going to provide an empty object. Just calling new browser window right here will automatically start up a new browser window on our desktop. So if we save the file at this point and then flip back over to our terminal again and run npm run electron, we'll see a new window immediately appear on the screen. So really, it's just that easy to get content, or at least a window, to appear on the screen. Now we're going to make great use of browser windows throughout this course because it is, without a doubt, the #1 way in Electron of communicating or interacting with our users. This browser window thing that we just created, we're going to refer to it as the main window because it's the main window inside of our application. I'll use the terminology browser window and main window somewhat interchangeably, and whenever I do, I'm really just referring to this thing that pops up that is intended to show content to our users. Now, I do want you to be really aware that this is, yes, very truly a browser window. I'm not joking there. If we go up to the menu up here and we find the View option and then click on Toggle Developer Tools, you'll see that we get our Chrome Development Console appearing on the screen right here. So we get some very familiar, and actually I said Chrome to be a little bit more accurate. I should say Chromium Development Console. We see some very familiar different tabs at the top here. So elements being all the different elements that might be displayed on the screen, a console where we can enter JavaScript commands, and so on throughout the list here. We'll use this development console right here to troubleshoot any running Electron code inside of this specific browser window. So remember, this browser window is going to eventually load up an HTML document to show some amount of content to the user. If we want to troubleshoot any code that is being executed by that HTML document, we'll use this terminal right here. This terminal, or this console, doesn't have the ability to interact with any of the code inside of our index.js file. So I want you to immediately start getting a little bit of a sense of where all the different code in our application is being executed. The best thing I can do is to point back to this diagram right here. The Electron app is being controlled by the index.js file. Now it does create the browser window, which we refer to as the main window right here, but we really want to think about these two processes as being 100% separate with no real direct means of crossover. We will figure out how to communicate between the two of them eventually, but for right now, again, I want you to think of these as being two separate running processes on our machine. Okay, so we got a browser window open right here. Yeah, that's fantastic, but it sure would be great if we could see some actual content inside of it. Right now, if we go to the Elements panel, there's absolutely no HTML elements inside this page, so clearly it's just a completely empty window right now. There's absolutely no HTML document loaded up into it. So to change that, we're going to create a new file inside of our project called the index.html file. And that's going to be the document that we load up into this browser window that gives the user something to actually interact with. So I'm going to change back over to my code editor, and we'll create a new index.html file. For right now, let's just add in a little bit of HTML boilerplate. So I'll place a head tag, a body tag, and then how about an H1? And inside this, we'll put the name of our application, which is video info, like so. Now that we've created the HTML document, we need to somehow instruct our browser window and tell it that it needs to load up this HTML document when it is first created and displayed to the user. To do so, we'll flip back to our index.js file. We're going to make use of the browser window that was created when we called new browser window right here. So let's assign the browser window to a new variable that we'll call main window. We can then instruct that browser window to load up that HTML document by calling the method loadURL. So this essentially means, okay, the window is now created. I want to now tell that window to go and reach out and load up some HTML document. We're going to pass the URL of the document that we want to execute as the only argument into the load URL right here. Now this string that we pass in can be absolutely any valid URL. So it could be something like, hey, show me google.com. Or in our case, it could be a reference to a HTML document saved to the local computer that we're running on. And that's what we're going to do in our case. So we're going to replace google.com right here with a reference to the HTML document that we just created. To do so, we'll use an ES6 template string. So I'm going to put backticks in. We're going to say, hey, I want you to load up a file using the file protocol as opposed to HTTP. Then we'll say, look at the current working directory. And we'll do so by specifying __ dir name, like so. This means, or this is a global variable provided by Node.js, which is the runtime that our Electron application is running on. So it essentially means look at our current working directory and find the index.html file. If you're on Windows, by the way, I really suspect that you might have to do a little bit of tinkering with this path right here. Off the top of my head, I think you might have to do a / if you're on Windows. So just be aware that if you get a 404, when we attempt to load this up, you might have to tweak this path just a little bit. Okay, so let's now try running our Electron application now that we're attempting to load up this HTML document and see what happens. So I'll go back to my terminal. I'm going to stop the running process, and then we'll start Electron back up by running npm run Electron again. Now when the browser window appears, we see video info appear, which means that our index.html document is successfully being loaded into this browser window. Okay, so that's pretty much it for getting some content on the screen. This whole process that we've gone through right here of creating or getting a reference to our application object, creating a new browser window, and then loading an HTML document into it is going to be something that we repeat through just about every application that we work on. And for any project of your own that you work on, I really expect that you're probably going to see a nearly identical chunk of code right here. So again, this is something that I expect to have to do very, very often. We'll create a new browser window and then load some HTML document into it. Okay, so another section that we've covered quite a bit of material. Let's take a quick break and then continue in the next section and start thinking about how we're going to add a little bit of interactivity to this HTML document. So I'll see you in just a second. In the last section, we kicked off our project by creating a package.json file and a index.js file. Remember that this index.js file is going to contain all of the logic related to our application having to do with the Electron side of things. So it's not going to be really concerned with rendering any content to any screens or handling click events or anything like that. It's just concerned about creating windows and handling the Electron side. We'll figure out a little bit more about exactly what that means in the future as well. In the last section, we also added in a require statement for the Electron library. Now, the Electron library is our main window for interacting with Electron in general. It contains a bunch of different functions and methods and properties that we can make use of for interacting with Electron. The most important property that sits on this Electron object right here is called the app property. Let's use a little bit of ES6 destructuring to pull that property off. So we'll say const app equals Electron. This app property right here represents the overall running process of Electron on our machine. So if we go back to our diagram over here, remember we had said that there was this overall running Electron app process, and we could use that to create stuff like other windows to display content to the user. This overall running Electron app process is created for free by us automatically by the Electron application or the Electron library when we first start our app up. Every other window that we show on our application or every other process that gets created is going to be something that we create ourselves. So this running Electron app process right here, it is made for free for us by the Electron library, and we get access to it by just looking at electron.app, usually with a little bit of destructuring, so it comes across with this type of syntax right here. This app object is really important because it gives us a view into kind of the life cycle of the running Electron application. Every time that we start up our Electron application, it goes through the exact same life cycle of events. So we've got kind of a timeline diagram here where we're starting off with Electron starting up at the very top and then proceeding through time down towards the bottom. When we first kick off our application at the command line, as we're going to do here very shortly, Electron is going to start up and create a brand new application process. Now this takes some amount of time in here. Like when Electron starts up, it takes some amount of time for the application process to actually be created. We don't want to try to interact with that app process before it is actually ready for us to submit events or commands to it. So what we usually end up doing is waiting for a ready event to be issued by the application process saying, hey, I'm all booted up now, I'm ready to start receiving some different commands. So we really have to wait for this app ready event right here before we start doing anything related to Electron on our side. Now, if that sounds a little bit confusing, hey, don't sweat it. It ends up being a very simple little bit of syntax. Let's flip back over to our code editor, and we're going to add on an event handler to watch the app object right here and get a message so that we know whenever it's ready to start receiving some commands. To do so, we'll write out app.on, then a string of ready, and then a second argument of an arrow function like so. This type of syntax that we see right here, we can refer to as event-based programming. We are watching some object, waiting for an event to be issued by it, and when that event is issued, we then execute this arrow function. We're always going to follow this exact same syntax, and we're going to follow the syntax many different times as we start to watch a lot of different objects inside of our application for different events to be emitted. So in general, we say app, or the thing that we want to listen to, .on, then a string for the event that we're listening to, and then an arrow function that will be executed whenever that event occurs. As you might imagine, the string right here of ready is a preset variable or a preset string that we know that the app is going to issue. There's many different preset events that are issued by Electron and all the associated libraries, and we can find a list of all those different events in the Electron documentation. But for this course, I'm definitely going to tell you about a lot of the different events that exist that we can make use of on the fly without having to look up documentation or anything like that. Once our application is ready, we can then start issuing commands to it inside of this arrow function right here. For right now, I want to just get started and just kind of do a little bit of a hello world type thing. Let's put a console log in here. We're going to say app is now ready. So now when we start up this application, Electron is going to automatically create the app object, and then we're going to listen for that app object to say that it's now ready to start receiving some events. When it is, we'll then just console log and say, yep, we're good to go. Okay, so let's figure out how to run our Electron application. How do we actually kickstart this thing? How do we actually make it do something interesting for us? To do so, we're going to use the Electron CLI. So we're going to very quickly realize that Electron is not just one simple library that we import into our code, but it's actually a whole platform with many different facets to it, or a lot of different surfaces to interact with. So we not only use the Electron library to kickstart this app process and do a lot of different interesting things, but we also use the Electron library to start our code and run the application. To do so, we'll open up our package.json directory, and we're going to add a new command to the script section in here to start our Electron process running. I'm going to find the existing test command, and I'm going to delete the entire thing, like so. Then we're going to add in a new command which will start up Electron and execute our index.js file. So I'm going to add on a new script that I'm going to call Electron, and whenever we run this script, we'll run the command electron dot, like so. Now, a couple quick notes in here. This is a JSON file, so do make sure that you've got double quotes around both the key and the value over here as well. You'll notice that we said electron dot right here. So that just means run Electron based on the current working directory. By default, Electron is going to attempt to load up the index.js file. So we don't have to actually specify index.js right here. It's going to just assume that that is the place where it should start. And it's assuming that's the place where it should start because of the main property right here. So Electron will say, hey, what's the main file that I should be executing inside this project? Oh, it's index.js. Okay, I get it. I'm good to go. Okay, let's save this file, and we'll flip back over to the terminal and run our project to see how we're doing. So back at the terminal, we'll run the command npm run electron. So this is how we invoke different scripts that we define inside that package.json file. We say npm run, and then the name of the script that we want to execute. So let's run that. And when we do so, we get a little bit of an error message. My mistake, I'm inside the wrong directory. There we go. Do it again. Okay, much better. So when we run that command, it looks like something's getting executed right now. We get this app is now ready console log inside of our terminal. And you may notice that we also got this process running inside of our dock down here. If you're on Windows, you'll see something very similar appear in your taskbar. If we click on it, well, it looks like I now see Electron inside my menu bar up here, but there's definitely no window or anything like that that I can actually click on or interact with. So remember, by default, that running Electron app process doesn't show any content to the user. It's just the process that is running, and let's pull the diagram back up. It's the overarching process that controls the flow of logic inside of our application. So it is not in charge of actually executing or showing the user any content or anything like that. We have to make different windows manually ourselves to actually communicate content to our users. Now, the last thing I want to do is figure out how to close this application, because obviously as it stands right now, it's not really doing a lot for us. If you're on Windows, or if you're on Mac OS, you can go up to the top left here and quit the application. If you're on Windows, you can right-click the running process inside the task bar down here and then select quit. And then the other process, or the other way to end the running application that's by far the easiest and works on both platforms, is to go back to your terminal and then press Control-C to end the running process. And when I do so, you'll see that the application disappears down here as well. Okay, so we covered a lot of different stuff in this section. We spoke a little bit about the app object, or the app property right here. We spoke about how we interact with the app object. Remember that it's usually going to be through the use of event-based programming, like so. And then we also figured out how to start and stop the running Electron application. So that's quite a lot of stuff to take in a single section. So let's take a break and then come back and figure out how to start expanding our application by creating a main window that we can use to display some content to the user. So let's take care of that in the next section. In the last section, we started talking about how we're going to use the IPC, or Inter-Process Communication System, to communicate from the main window over to the Electron side of our application. The idea here is that we're going to put all the logic around determining the duration of a video on the Electron side of our app. So the main window will say, hey, I need information about this particular video. The Electron app will figure out that information and then send it back on over to the main window. Let's put together the first bit of IPC inside the main window, where we are going to send a message from the main window over to the Electron application. After we do that first little bit of work, we'll then come back to this diagram and talk a lot more about how these different events work. And I'm also going to tell you a little bit about a big gotcha inside of here as well. Okay, so back over to our code editor. I'm going to open up the index.html file where we had just imported the IPC renderer object. So we're going to add in a little bit of code to communicate the path to the given file over to the Electron side of our application. So essentially, we're kind of like right here. We want to send a message over to the Electron app and say, here's a video file, please do something with it. So inside of here, I'm going to give myself a little bit of space underneath the line where we pulled out the file details. Remember that this file object right here had the file name, the file path, the size, and the last modified date. Now we did already take a look at the Fluent FFmpeg module, and we saw that really the only detail about the video file that we needed to figure out the video file size, or the video file duration, was the path to the file. So I don't really need all the different properties inside this file object. I really just need the path. That's the only thing that I care about. So I'm going to destructure the path property off of that file. So now path right here is a string pointing to the location on our file system of the video file that we're trying to get some information about. So now I want to take this path and somehow message it over to the Electron side of our application. To do so, we'll use the IPC renderer object. So we'll say IPC renderer.send. So I want to send a message over to the Electron side of my application. I need to provide as the first argument an event name. Because we are sending this function, or excuse me, because we are sending this event right here, because this is an event that we are making up, like you and I, the developers, we get to choose what we want to name the event. So this can be absolutely any name that we want. We can do something like get video file length, or get length, or video submitted, whatever. You get the idea. It can be absolutely any string that we want to call this event. In practice, I really recommend that you stick to some kind of convention for naming your different events here, just to make sure that it's really clear to you in the future when you come back and look at your code to figure out exactly what's going on and what you're doing here. In my case, I like to use a type of colon syntax that I learned way back when I used to write Backbone code for a living. So Backbone was very heavily event-based, just like this IPC render stuff is. And the convention over there was that you would write out the name of the thing that you're dealing with, and then kind of the action or the verb, kind of like a noun colon verb syntax. So in this case, the event that was just triggered, or the event that we're sending along here, a video was submitted. And so I would say video colon submit. Again, this is just my personal take here. It is not necessarily the right solution. So if you want to go a different route, hey, totally up to you. It's totally fine. Now the second argument to this send function right here is going to be the data that we actually want to send over to the Electron side of our application. Again, remember, the only thing that we really care about here is the path. So as a second argument, the piece of data that we're trying to communicate over to Electron will be the path, like so. Okay, so looking back at our diagram, we have really just accomplished this part right here. We have said, main window, you need to communicate something over to the Electron app. Now the Electron app has to be set up to receive this message. So it's two-way communication. We have to instruct main window to send the message, and then the Electron app has to be set up to receive the message as well. Now this is where things start to get a little bit dicey. And there starts to get a little bit of a gotcha here on the event communication, or the IPC system. So I've got a little diagram that's going to help us understand exactly what the trouble is here. Okay, so the trouble is, and this is something that we're not going to quite see until we start to get to the second process, or the second part of this event process, but essentially the little gotcha is that the names of all these functions are a little bit misleading, like not the easiest thing in the world to keep in your head. So at this point, we issued a message by calling IPC renderer.send, right? Like that's what we just did. We used that to send a message over to the Electron side of our application. Now, here's where things get weird. On the Electron side of our code, to receive that message, we're going to refer to IPC main.on. So notice that we're not looking at the same object here. On one side, it's IPC render. On the other side, it's IPC main. In my opinion, that's a little bit confusing. Why couldn't it just be a name of something like event bus or my event object or something like that? You know, something just to keep the object names the same on each side of our code base. Now things get even more weird when we want to send an event or send a message from Electron back over to the main window. So when we want to communicate from Electron back to the main window, we're going to reference main window.webcontents.send. And so again, you'd kind of think it would be something like IPC main.send, but no, it's definitely not. It's main window.webcontents.send. So again, the only reason I say this is a gotcha, the only reason I say it's weird is because you'd really expect all these objects that we're working with to have very similar names, but they really don't. It really always feels like there's a special case on each side that we have to deal with. Having said that, these are the 4 objects that we have to keep in mind whenever we are dealing with communication between processes. So if you screenshot this diagram right here, or if you just jot down a couple notes about this thing, put a couple of comments in your code or something like that, you'll definitely be good to go. So this is really the extent of as weird as it gets. I just wanted to point this out ahead of time as an easy place to kind of slip up. Okay, so with that in mind, we have now sent an event from the main window over to the Electron app. So now let's open up our Electron app file, and we will receive the event by using this IPC main module. So back inside my code editor, I'll go back to the index.js file. Here it is right here. The first thing we're going to do is import the IPC main object from Electron. So we'll say IPC main. Then we can use a very familiar event listening syntax. So we'll say IPC main.on. As the first argument, remember, we specify the event that we're going to listen for. So in our case, we want to listen for when the main window throws out the message video:submit. So over inside of our index.js file, we're going to listen for the message video:submit. And then the second argument will be a callback function to execute whenever this message is received from the main window. Okay, we've covered quite a bit on the IPC side of things. So we've now got the ability to send a message from our actual web window or the web contents. We're sending the message from this process over to this completely separate, completely different, completely unrelated, completely decoupled process that houses our main Electron application. So this is a good place to take a break. Let's take a break, and we're going to come back and fill out some of the implementation to figure out the actual duration of this video file, and then we'll send it back over to the main window. So let's take care of that in the next section. At this point, hopefully you have FFmpeg installed on your local machine. You can make sure that it's working as expected by opening up your terminal and running FFmpeg like so. You should see some type of message like this appear on the screen. Now that we've got FFmpeg installed, we can start to think about how we are going to interface with it or interact with it from our actual application. So the first thing I want to do is talk to you about the actual flow here. Like, what are we actually doing? How are we going to use FFmpeg? So let's kind of visualize the process. We're saying that when a user selects a given file and then clicks the submit button on the form, we need to somehow take some of the file details and feed them over to Fluent FFmpeg, which is going to read the actual video file duration. We're then going to take the return duration and somehow show that back to the user. So pretty clear process right here, at least in terms of, overall flow. The actual implementation certainly is going to be a little bit more challenging, but the overall flow is take video file, feed it into FFmpeg, get duration, show to user. Definitely something, I would say that's pretty palatable. Now here's the hard part. Here's the real challenging part. Where in the world are we going to place all the logic for these steps? How are we going to somehow call FFmpeg and get the video file duration? Where are we going to locate that code? So this is something that starts to kick off somewhat of a religious debate inside of the Electron world. Really, the discussion that we need to decide here is, does it make more sense to locate this application logic on the Electron app side of things or in the web app side of things? And so to put that another way, what we really are trying to ask here is, should we place some code to fetch the duration of the video inside of the HTML document, so inside of the web application side of our application, or should we place it inside of the index.js file, which is the Electron side of our application? We're going to follow a very strong convention throughout this entire course, where we are going to locate as much logic having to do with the underlying operating system or interacting with a CLI or anything like that inside of the Electron side of our application. The idea here is that the Electron app will contain all Electron-specific configuration and logic. Any underlying operating system logic, anything like that is going to be stuffed into the Electron side of our app. By doing so, we can keep the web app side of things as generic and web only as possible. The idea here is that if we keep any operating system specific stuff out of our web app, it increases the likelihood of us being able to reuse that application as a plain web application. Like we could take this web app right here and throw it up on a web server and just treat it like an actual web application that a user can get access to. A good example of this would be the Slack chat client. So with Slack, you can either open it up inside the desktop application or you can open it up online. There's clearly a tremendous amount of code sharing between those two clients, and it's always going to be easier to enable that code sharing if you keep a lot of the Electron related code out of the web app side of things. So again, this is the convention that we're going to follow throughout the entire course. Anything related to underlying operating system or accessing file system, anything like that, we're going to stick into the Electron side of things. So with that in mind, now opens the door to a really interesting question. If the index.html file is where we detect the actual file being submitted and we get the actual file details right here, how in the world are we going to actually communicate that detail back to the Electron side of our application? Remember that right now we're opening up this browser window and we're loading an HTML document into it. So we need to somehow communicate from this HTML document right here back to this file, back to this chunk of code, back to the Electron side of things. To put it into a kind of diagram format, we can kind of imagine as looking something like this. At some point in time in our application, the main window is going to say, hey, I need some information about this video, and it needs to tell that or communicate that somehow over to the Electron side of our application. Then once the Electron application has done its amount of processing, it should be communicating back over to the main window. Hey, okay, like I did the video introspection, I looked at the video file, I got the duration, here's the duration that you asked for. So it's clear that we need to communicate from the main window over to the Electron app, and then from the Electron app back over to the main window. To do so, we're going to make use of the IP system, or the inter-process communication system inside Electron. The IPC system is used to communicate between different running processes inside of our Electron app. And so that's exactly what we have here. We've got the running Electron app process and the main window or browser window process as well. So we're going to use the IPC system to send a message from the main window over to the Electron app, and then from the Electron app back over to the main window. So with that in mind, let's get started with the IPC system inside of the main window and figure out how we can send a message over to the Electron app side of things. I'm going to flip back over to my code editor, and I'm going to open up the index.html file. Now, as we start to work with this IPC, or inter-process communication system, it's really going to open up a huge can of worms. But it's going to be very good because we're going to learn a lot about Electron, by the way, or as we go through it. Excuse me. Okay, so the first thing we're going to do is where things start to get immediately very strange. The IPC system, remember again, I'm going to say this only a finite number of times, but inter-process communication. So IPC, inter-process communication again. That IPC system is accessed through the Electron module. Remember how we got access to the Electron module in the past? Back inside the index.js file, we required in Electron at the top. And so that's what we're going to have to do inside of the index.html document. So let's write out the code for this, and it's going to look a little bit strange to see it inside of an HTML document, but well, let's just write the code and then you'll see what I'm getting at here. Let's say const electron equals require electron, like so. Okay, so I don't know about you, but seeing a require statement inside of some HTML code or some code that's being executed on the client side or in our browser is very, very strange. And let me tell you why. Remember, the require statement, as we spoke about a little bit earlier, it makes use of the common JS module system, which is the module system used by Node.js, not our browser. So if we open up Chrome right now, let's open up Chrome. So here's my web browser, and I'll open up the console, and I put in require. I get the message require not defined. So our browser, Chrome, has no idea what CommonJS is. It has no idea what modules are. It has no idea whatsoever. However, those restrictions get removed when we are making use of Electron. I'm going to pull open the Electron window, so I've still got the browser window running right here. And I'm going to open up the developer console. Here we go. And inside of this window, I'll say require. And so over here, wow, this is interesting. Chrome, the browser, has no idea what the require keyword is or what the require function is, but our browser window inside of Electron sure does. So what's going on here? It looks like these two different, what we've said previously was always like, yeah, it's a browser, it's a browser. Clearly, the browser window has some additional capabilities that Chrome does not. So let's expand on this a little bit. Okay, so here's what's really going on behind the scenes. When we execute code inside of a browser window, or like our main window, it has access to essentially two different runtimes or two different big bundles or code bases. It has access to both all of the conventions and all of the modules that are built into the Node.js runtime, and it has access to all the different modules, files, everything that exist inside of the browser as well. So we can really think of this main window object or this main window browser window where we are executing all of our code as being a supercharged little piece of JavaScript that we have access to. It has access to not only all the code that we would write inside of a Node environment, but all the code that we would write inside of a browser as well. And so in practice, that means that we can make use of require statements inside of code that runs inside of this browser window. And we can access a lot of built-in modules that exist inside of Node, like the file system or the cryptography module as well. So I could go back over here to the browser window and say require fs. And that accesses the file system module, which means we could access the file system directly from this browser window right here. Okay, so essentially long discussion there just to kind of explain to you that inside of this browser window that we are making access to, we can directly require in modules without making use of a extra module bundler like say Webpack or something like that. So getting back to our code, we've added in that const electron equals require electron. Again, this line right here is what is really unexpected if you have been writing a lot of front-end JavaScript code. Then underneath it, we are going to continue on by going back over. So we're now stopping the discussion about require. We're going to go back to talking about that IPC or inter-process communication topic. We're going to get access to the IPC system by pulling a function off of the Electron library. And that function is called IPC render, object, not function. So the IPC render object. We're going to pull that off of the Electron library. So this IPC render object right here is what is going to allow us to communicate from this browser window that we're executing this HTML document in, or that is executing our HTML document. We're going to use the IPC render to communicate from this document back over to the Electron process that is hosting this browser window. So this IPC render right here, this is really our window to the world. This is what we can use to communicate with other parts of our Electron application. Okay, so this is turning into quite a long section. So let's take a break right now. And when we come back, we'll make use of this IPC render to communicate from the browser window side of our app back over to the Electron side. So let's take care of that in the next section. In the last section, we were able to successfully console log out the duration of the video file. In this case, our video file is 2.55 seconds. So now the last thing we have to do is somehow get this duration and send it back over to the browser side of our application, receive that data, and then somehow get it to appear on the screen. So looking back at our diagram for sending around events or sending around data between different running processes using IPC, to send information from the Electron app over to the main window, we'll call main window.webcontents.send. Then we'll specify an event name and the actual data that we want to send back over. Then inside the main window side, we can refer to ipcrender.on and listen for that particular event. So let's give it a shot. Inside of the arrow function, that was the callback for the FF probe call, I'm going to delete the console log, and then we're going to replace it with a reference to our main window. So looking back to the diagram, again, it was main window.webcontents.send. So main window webcontents.send. So that's the function call. However, we've got a little bit of a very subtle bug right here, a very, very subtle bug. And I'm going to ask you to see if you can spot it. And if you can't, hey, obviously don't sweat it. So what might be going wrong here? If we run the code as is right now, I would actually expect to see a big error message appear on the screen. I would expect that after we submit the video, or after we attempt to get the duration, I would probably expect to see something like cannot read property web contents of undefined. So why would that be? Well, it goes back to basic JavaScript and basic scoping rules. Look at where we define the main window variable inside of our application. Right now, the main window variable is being defined inside of this event handler right here, which means only this arrow function has access to the main window variable. Nothing else inside of the application can read what the main window is. To make sure that main window is properly scoped inside of our application, we usually follow a very simple pattern throughout all of our different Electron applications. So here's what we do. Above any event handler, we define main window with the let keyword. And then we don't set it equal to anything. We just say, hey, this main window object, this main window variable, it exists. Just so you know, it exists. Then down inside of the app.onReady call, I'm going to remove the const keyword so we don't attempt to define the variable twice. So let's now run through the order of operations here inside of our code. When Electron first boots up, it's going to declare a variable called main window, and it's not going to assign it a variable of any kind. So it's going to start off as undefined. The next thing that happens is going to be our app.onReady call. So app.onReady will be called, the arrow function will be executed, we'll create the new browser window, and then assign the browser window to the variable main window. So now, main window right here, for inside of the scope of the entire program is set equal to the browser window. That means that any other function that we define inside this file can access main window and reference the browser window that was assigned to it. So again, this is not necessarily something that is really related to Electron. This is just basic vanilla JavaScript and basic scoping of variables inside of JavaScript. This is another area where if any of this looks confusing, feel free to reach out to me on the forums and I'll give you a better example of exactly why we are defining this thing ahead of time. Okay, so I think that we're in a better state now for doing this webcontents.send call. The webcontents.send function right here is going to have a nearly identical function signature to the IPC renderer call that we had set up inside of our index.html. So the first argument will be an event name, and then the second argument will be some amount of data that we want to send along with the event. I'm going to follow the same event naming convention that I was using before. So I'm going to say the thing that we are talking about, so video, then a colon, and then the thing that kind of happened to it, which was to fetch metadata. So again, this event name right here, you don't have to use the same thing as I. You can name this got video length, or it could be something like here's the duration, whatever you want it to be. It's totally up to you. You just have to make sure that you name it consistently on both sides of the send and receive. Okay, so I am going to stick with video colon metadata. And then as a second argument, we're going to stick in the actual duration of the video, which remember is metadata.format.duration. Now I'm going to multi-line this function call just so you can see my code more easily. Remember that I run my code editor really zoomed in just so you can very easily see what's going on. But if I wasn't so zoomed in, I would definitely leave this all on a single line. So honestly, if I were you, I'd probably leave it all on a single line. Okay, so we are now at this stage right here. So we have received the initial event, or we sent the initial event. We received it inside the Electron app. We did some amount of calculation or some long-running process over here, and now we are ready to send the result back over to the main window. So we just use webcontents.send to send a message back over to the main window. So now inside the main window, we can receive that message by referencing ipcrenderer.on. So we'll go back over to the index.html file. And inside of here, I don't have to put the receive call inside of the form submit handler. I can really put this event handler absolutely anywhere I want. So I'm going to place it just directly underneath the form submit handler. Again, there's really no reason to place it inside of it. So outside, I'll say IPC renderer, and we're going to listen to a message in this case. So we're going to say .on. I want to listen for the event video : metadata. And when we receive this, we'll run this arrow function. The arrow function is going to have the exact same arguments as all the other or the previous event handler that we put together. So the first argument is going to be the event object, which describes a bit about the process that sent this message. And then the second argument will be the duration of the video. So that's the actual data that we sent along. So here's the duration right here inside of the index.js file. So we're going to take this duration and we need to somehow get it on the DOM. We need to somehow get it on the screen. Again, if we were using jQuery or Angular or React or Backbone, whatever it might be, we could figure out some fancy way of doing this. But in this case, we're just using vanilla JavaScript. So really no reason to get complicated here. We'll just make a hard-coded h1 script tag, or excuse me, h1 tag inside of our HTML document, and then set the value or the inner HTML on that when we get the message back. So underneath the form element, I'm going to put in an h1, and I'm going to give it an ID of result. It's going to start off as empty, so when the application first renders, the h1 is not going to have anything inside of it. But then when we receive this event saying, hey, we found out the duration, here it is, we'll then select that h1. So we'll do a query selector to get the tag with the ID of result. So this right here is the h1. And then we can set the content inside of it by saying inner HTML, and that's going to be a string. And I think this would be a good place to use an ES6 template string. So I'll place backticks here. We'll say video is $ curly braces, duration, and then seconds, like so. Let's zoom out so you can see the whole line for just a second. Okay, that's better. Okay, so again, find that h1 that we just added in, set its inner HTML or set its visible content to be the string video is this many seconds. All right, so I think we're ready for a big test here to see how we're doing. Now we have done quite a bit of editing of the index.js file. Remember, whenever we change the Electron code side of our application, we have to restart the process in the terminal. So back at the terminal, I'm going to find my running Electron process. I'm going to stop it, and I'll start it back up. So now I will choose my video file. I'm going to select any old video. I'll hit get info, and I get my message that appears to the user. Hey, your video is 2.55 seconds. Of course, we can always select a different video now. So here's a different video. Okay, this is a converted video, so it's the exact same length. Let's try this one right here. Okay, there we go. So this video file happens to be 15.71 or 72 rounded, I guess, seconds long. So awesome. Looks like everything is working as we expect. So that's pretty much it for this first application. Let's take a quick break and continue in the next section and do a wrap up and review all the different things that we learned while putting this application together. In the last section, we got some content to show up inside of our browser window. Now that we have some content available here, we can start to think about adding in some application-specific logic. As a reminder, we want our application to show a small form to the user. We'll prompt them to select a video. They can click on this button right here to select a file off their hard drive, and then they can click on this button to submit the form and get the total length in seconds of the actual video. I think that we can probably start off by opening up our HTML document and editing it to show a form. So let's get to it. Back inside my code editor, I'll open up the index.html file, and we'll add in some additional markup inside of here to show a form to the user. Remember, the entire point of Electron is that we are using common web technologies to interact with or display content to the user. So we're not using any fancy Electron stuff to add a form. We're just using HTML, plain HTML, to show a form to the user. Now, one quick aside I want to throw out there as well. We could just as easily load up a framework like React or Angular or anything else you could possibly imagine, Vue.js, Riot.js, anything, to produce the HTML inside of this application. But because this is our first app and we want to start nice and simple, we're just using vanilla plain HTML and vanilla plain JavaScript as well. Okay, so inside the body tag, underneath the H1, we'll add in our form. And then inside the form, I'm going to add a div that's going to wrap our input, or excuse me, our label. So I'll place a label, and it'll say to the user, select a video, like so. Now that we've changed the HTML markup of our application, we can flip back to the Electron window with the running browser process. Whenever we change some content related to, or some code related to the content of the browser window, we don't have to fully restart the application at the command line. Instead, we can just hit Command R if you're on OS X, or Control R if you're on Windows, or F5 if you're on Windows as well. Alternatively, you could also go up to View and hit Reload right here as well. So because the change that we just made was related to the actual markup of the browser window, again, we didn't have to actually restart the entire application. We only have to restart the application when we change Electron-related code, or the stuff inside of the index.js file. Okay, so definitely looks like we got our label appearing on the screen. That's exactly what we added in right here. So here's the label. So now we get to start thinking a little bit about the button that a user is going to click to select an actual video file off their hard drive. So this is going to start up a pretty interesting conversation that we're going to have several times throughout this course. And that conversation is, well, if we're reading information off the user's hard drive, and that's what we're doing here, right? When we select a video file, we're reading information off the user's file system. Can we do that using just technology in the browser, so like just vanilla HTML, or do we have to somehow involve Electron in that process? Do you remember one of the diagrams I showed you earlier? I showed you this diagram right here. I had said when we were talking about HTML applications, or I should say complex web applications, we had said that one of the big limitations of them was that they couldn't access lower level functionality on your machine. And as an example, I'd said, hey, this can't access your hard drive. And so we think when we start thinking about pressing a button inside this application that's going to somehow read a file off the user's hard drive, you might be thinking, okay, well, this is something that we're going to use Electron for, right? We're going to use Electron to show a file picker of some sorts to the user, and they'll use that to select an actual video file. Well, not quite. You see, I might have exaggerated just a little bit by saying that the browser can't access your hard drive. There actually are some very limited situations in which your browser can read files directly off your hard drive. So let's explore this a little bit more. So here's the real limitation between Electron, or where we really draw the line whenever we're thinking about reading files directly off the user's machine. When we're working with a traditional web page, and when we say traditional web page, we can just as easily think about the browser window that we have right here. The browser window can easily get files about a user purposefully feeds into it by using an input element or an input tag using vanilla HTML. The difference between a web page and Electron here is that a web page can only read details about a file that a user very purposely feeds into it. So this would be a file that, like, the web page opens up a file picker, we select a file, and then boom, we get some details about that very particular file. Electron, on the other hand, and code that we write using Electron, has permissions to read absolutely any arbitrary file off the machine at any given point in time. So with Electron, we get complete control over the operating system, or I should say over the file system, and we can read any file that we want to. However, in this case, we're asking the user to select a single video file for us, and we don't really care about any other particular video files. So we can use just vanilla HTML that doesn't really depend upon Electron or anything like that to select an actual file for the user to use. So let's see what this will look like in practice. I'm going to change back over to my code editor. I'm going to find the label tag that we put together, and right underneath it, we're going to use some very vanilla HTML to show a file picker to the user. I'm going to place an input tag. I'm going to give it a type of file, and I'm going to tell this input that it should only accept files that are of type video that the user selects. So this is going to make a file picker type input that only accepts video files as inputs. So let's save this and refresh our browser window and see how we're doing now. So when I refresh the document, we see choose file appear on the screen. So this is the default Chrome, or Chromium, again I should say, input file picker. So if we click choose file right here, we then get prompted to choose an actual video file. You'll notice that in this file picker that got spawned, I can't really select any PDFs or PNGs or images. I can really only select image files, or excuse me, video files like this one right here, AAAA. So if I open this file up, it then gets loaded into this input right here, and I can easily click the input again and select a different video file. So again, with this type of input that we're expecting from the user, we don't really have to make use of Electron or anything fancy like that to read files directly off the file system. We can just make use of some existing HTML elements that allow us to access individual files that a user provides to us. Now later on in the course, we'll look at a couple different methods for reading directly off the file system. But the reason I show you this very basic, very simple method right here is just to remind you that we still have access to all traditional functionality of the browser inside of these browser windows. So there's really no need to automatically assume that you need some fancy Electron code to work with the underlying operating system if there is still a workaround using traditional HTML elements or traditional JavaScript. Okay, so back on topic, we've now got our single video file loaded into the application. Let's continue in the next section and continue working on our application. I think that we've spent quite a bit of time doing a little bit of lecturing about what Electron is and some of its background. And so I think at this point, it'd make a lot of sense to get started on our first project and really get our hands on some Electron code and figure out how it works internally. If you've ever taken one of my courses before, you know that I love teaching via projects. So everything we do in this course is all going to be themed around projects. So at the end of the course, when we're all done with everything, you'll have some nice examples to refer back to for doing various tasks with Electron at some point in the future. So let's talk about the first project that we're going to be working on. Now we're going to start with an example that's a little bit more simple, a little bit more straightforward. It's still going to be very fun and very useful, but we're going to be focusing really on the internals of Electron and how you get started working with the very basic elements of Electron. So it really will be a lot of fun. Okay, so this is what we're going to build right here. You can see that on the exterior here, I've reflected just like the desktop of your computer. So I just want to make sure that it's really clear. Yep, this is a desktop app, not a browser or anything like that. So we're going to be building everything inside of this window right here. The idea behind this application is that we're going to allow the user, so like, essentially you or me, but we can imagine our user, to select some video file that is sitting on their current machine, so sitting on their computer right now. Once they select some file, they can then click this Get Length button. After they click Get Length, we'll write some code that will inspect that video file that they selected on their local machine and determine exactly how long or how many seconds the video is. So this might seem like a little bit of a straightforward project, and well, yeah, it is, but we're going to learn some very, very interesting things about the core concepts around Electron. So it will be a very useful project to get started with. I want to talk to you a little bit more about some of the architecture that's going to go on behind the scenes with this application. because even though we could make this very straightforward and confine it to just a very small amount of code, we're going to jump through a couple of extra hoops just to make sure that it's really clear exactly what Electron is doing for us. So let's talk a little bit about the architecture that we're going to use to build this application. Now we're going to see the same architecture throughout all the different projects that we work on in this course. So if the first time we go through it, it doesn't seem super clear, hey, don't sweat it. We're going to repeat this several times again. So here's the general idea. When we create our application and then we execute it, however we execute it, and we'll figure out exactly how we do that, two different important pieces of code or two different important objects are going to be created. The first is what we'll refer to as our Electron app. The Electron app right here we can think of as being like the overall Chrome process. Remember when we were just talking about our browser and how Electron works just like Google Chrome? We can think of the Electron app as being like the main overarching process that controls everything that's going on inside of our application. We create this Electron application by running our program at the terminal. So when we run this command or when we run a command to start the application, our app will automatically create this Electron application. Once the Electron side of our application boots up, it will then automatically create what we'll refer to as the main window, which we can really think of as being just like the browser window. So this main window is where we will display some amount of content to the user on the screen. And so you can see that I put the diagram of a web browser right here. Again, remember that we're not going to see like a full-fledged web browser with forward buttons and back buttons or an address bar. I just mean to say, hey, remember behind the scenes, everything that we're working with here really is a browser window. And when we actually create this main window, I'll do a couple things to really prove that to you, to make you really understand that, yeah, we're really just still working with something that's just like Chrome. When the main window opens up, remember it is a browser window, and browser windows always show HTML documents. So we're also going to create an index HTML document whose purpose is going to be to show the actual form and buttons on the screen. So that's pretty much it. That's the overall architecture for the application we're going to build. At the end of the day, I'm going to expect that we're going to have two separate files. One JavaScript file that will be responsible for starting up the Electron application and then creating our main window, and then a second file, the index.html document, that is going to contain all the actual form elements and all the form event handlers and all that kind of good stuff. So that's pretty much it. Let's take a break and then we're going to come back in the next section and get started with this application. In the last section, we added our IPC main call inside of our index.js file. So remember, this listens for an event from our main window called video:submit. Whenever the main window emits or sends this event, this arrow function right here will then be executed. So this arrow function is going to be our time to make use of FFmpeg to actually figure out the duration of the video. Now the first thing we have to do is figure out how we can receive the file path that was sent from the IPC renderer call over here. So remember, as a second argument, we wanted to communicate what the path to the video file was that we wanted to look at. So back inside of our index.js file, we can get access to the data that was sent to us from the browser window by looking at the second argument to this arrow function. The first argument, by convention, we call the event object, and it has some data about the process that actually sent this event. So you can easily imagine the case in which maybe we've got 5 separate windows inside of our application or something like that. Maybe we've got 5 separate windows and any one of those windows could somehow trigger this event right here. We might want to know explicitly which of those windows sent the event, and we could use the event object to figure that out. In this case, however, we've only got the one single window, and so we don't really need to make access to this event object at all. We really just care about the second argument, which is going to be whatever information was sent over to us by the event emitter, or the thing that sent the event. So for us, it's going to be the path to the actual video file. Okay, so now that we've got the path to the video file, we can start working on the FFmpeg side of things. To get the duration of a video file, we're going to make use of that Fluent FFmpeg module. Remember that Fluent FFmpeg is simply a wrapper around the FFmpeg command line interface. And so it's just a thing that makes working with FFmpeg a lot easier for us inside the node environment. Let's import the module, or require it, at the top of this file. So we'll say const ffmpeg is require fluent-ffmpeg. Then down inside of the event handler, we can get the duration of the video file by calling ffmpeg.ffprobe. The first argument is the path to the actual video file, which is path. Remember, that's the thing that we passed over or we received from the event. And then the second argument is a callback function that will be called after ffprobe has completed running. So remember that ffprobe right here has to actually reach out to the video file itself and read some details about it. That's something that takes some amount of time. Whenever we are writing node.js code, if we ever have some operation that takes some amount of time, traditionally we will add in a callback function that will be called after that process or after that kind of long running operation has completed. And so that's why we're using a callback function here to receive the actual duration of the video file. So we'll add in an arrow function. Again, this will be called after ffprobe has completed running. The first argument to it is going to be an error object, and then the second object is going to be the thing that we actually care about, the metadata object. So I'm calling this metadata right here because the thing that we get back from ffprobe is not just the video duration. It has a lot of information about the video format, when it was last edited or created, its encoding, its size, its bit rate, its audio. All these incredible quantity of different properties are reported by ffprobe. But for us, we just care about the actual duration of the video file. So we're only going to be reading a very small segment of this entire big object that describes the video file in total. I think that at this point in time, we'd probably be well served by maybe adding in a little console log here just to make sure that we're going down the right path. So inside of the callback function, I'm going to add on a console log of metadata. And then I've already taken the liberty of looking up the property that we want to take a glance at ahead of time. So we're going to console log out format.duration. And maybe ahead of this thing, we'll give ourselves a little message. Maybe we'll say like file length is, and then the comma and the actual video file duration. Yeah, it's really file or video duration. Let's change the text there. That makes more sense. Okay, video duration is. All right, let's give this a shot now. Keep in mind that we have now edited some code inside of the Electron side of our application. So we need to restart the entire application. We can't just refresh the browser and expect everything to work. We have to actually, restart the entire app to make sure this new code on the Electron side of things kicks in as well. So I'm going to go back to my terminal. I'm going to find the running Electron process. I'll end it, and then I will start it back up with npm run Electron. Okay, so now in theory, if we choose a file and click submit, we should see a console log over here that tells us the duration of the file. So here's my video file. I will get info, and immediately in the console, I see video duration is 2.55, which is recorded in seconds. So my video file right here is 2.55 seconds. Awesome, looks like it works. So that means that all we have to do now is somehow take this duration, communicate it back over to the browser window side of our application, and get it to appear on the screen. So let's take care of that in the next section. In the last section, we added on a traditional HTML input to allow the user to select a single video file off of their file system. Now that a user can select a given video file, we can add on an additional button to the form to actually submit it. Once the user submits the form, we'll then add in some JavaScript code that will read some details about that particular file they selected and somehow communicate the length of the video back to the user. So let's get started. The first thing we'll do is add a button to our form that will allow the user to actually submit it and say, okay, I now want to get some details about this video file. So underneath the div that we had placed, but still inside of the form, let's place a button tag with type submit, and we'll give it the text of get info, like so. So now if we go back over to our application and refresh it, we now see the get info button appear on the screen. So now we can kind of go through the full workflow here where we select a video file and then click get info. Now right now, the form attempts to submit itself in a very classic HTML way, but we want to add on some event handler to the form itself to say, hey, if you attempt to get submitted or if the user tries to submit you, don't actually post the form anywhere. We want to run some custom code that's going to inspect some of the inputs that are inside this form. To do so, we're going to need to use a little bit of JavaScript inside of our application to watch for the form event submittal and then eventually handle it in some fashion. To do so, we'll just add some JavaScript code directly to our HTML document inside of a script tag. Now, of course, on a large production scale application, we're definitely not going to add inline JavaScript to an HTML document like so, but we'll talk about strategies for adding in a lot of custom logic to our application in the next section, or the next application we work on. For right now, I just want to have the ability to execute some JavaScript code whenever the user attempts to submit the form. To do so, we'll add in a little bit of very vanilla JavaScript. So absolutely no need for jQuery or React or Angular or anything like that here. We can use some vanilla JavaScript to add an event handler to watch for the form submittal. We'll say document.querySelector form. So this line right here will select the form tag, and then we'll add an event listener to it. So we'll say .add event listener and watch for the submit event of the form. So first, select the form, add the event listener to watch for when the user attempts to submit it. Then as the second argument, we can pass an arrow function that will be called whenever the user submits the form. The first argument to this arrow function right here, or this event handler, is the event object, which represents the actual submittal process of the form. To make sure that the form doesn't attempt to submit itself, we'll call event.preventDefault. Okay, so all the code that we just added in here, this is absolutely nothing specific related to Electron at all. This is all very vanilla JavaScript that I would expect to see inside of any traditional web application of any type. So nothing specific to Electron in here. If any of this code looks mysterious at all, feel free to drop me a message and we can talk about some of the interacting with form elements and event listeners with default or vanilla JavaScript. Now remember what we're trying to do inside of this event handler. Inside of here, we want to look at the file that the user selected inside this file input and then get some details about that particular file. Now we'll talk about exactly how we are going to get details about that file, but for right now, I want to figure out just how do we get more information about the file that the user selected. To do so, let's do a little bit of troubleshooting inside of our code right here. I'm going to place a debugger statement inside of the event handler. So I'm going to write out the word debugger. Now, whenever we execute our code and submit the form, the browser window that we have running will pause execution of our code on this debugger statement right here. And we can use that as an opportunity to inspect the actual form itself and get some more details about what's going on and how we're going to interact with the form. So let's go through the process of submitting the form and getting this debugger statement to pause for us. So I'm going to open up the Electron window again. I'm going to first refresh the browser window by hitting Command R. Remember that you can always go to View Reload as well up here. Once I have the browser window refreshed, I'm then going to open up the Developer Console by clicking on Toggle Developer Tools right here inside the View menu. If you're on Mac OS, by the way, you can press Command-Option-I to toggle that. And if you're on Windows, I believe you can hit F12 to toggle the menu as well. Okay, now that we've got the developer console open, we can go through the process of submitting the form, and then we should pause execution on the debugger statement that we had placed. So I'll click on Choose File. I'll select a video file that I've got on my desktop, and then I'll click on Get Info. So the instant that I do, I pause in execution, I get the big message up here that says paused in debugger. So the execution of my JavaScript code is paused on this line right here. So at this point, we can write some JavaScript code into our browser console and get a better idea of exactly what we're working with the input tag up here. I'm going to press the escape key, which will bring up the console at the bottom of the window. I'm going to drag this thing down just a little bit to give myself some space to work with. So remember, the goal here, what we're trying to do is to look at the form, to get a better idea of how we access some of the details about this particular file that the user selected. So I'm going to start off by maybe selecting this input tag right here. I'm going to use a little bit of vanilla JavaScript to select the input tag, and then we'll see if we can't kind of get a handle on the file from there. I'll select the input by writing out document.querySelector, and I want to select the input that is visible on the screen. Okay, so that definitely returns the input. You can see that when I mouse over it on the left-hand side, it gets kind of highlighted as being the input that we're working with right here. Now to get access to the files that have been selected inside the input, we can write out the same document.querySelector input, then .files. And this will give me a list of all the different files that the user has selected. Right now, I've only selected a single file, so it has a length of 1. If we expand this file list object, we can then expand the file that was selected, and we'll see some details about the file that the user selected. So we see some stuff about the last modified date, the name of the file, the path to the file, and the size here. You will notice that there's nothing about the actual length of the file. So this definitely gets us the path of the file, but really not much else beyond the path, the name, and the size. So we're going to have to figure out some really clever way to actually read the duration of the video file. But hey, at least we've got some information about the actual file itself. Let's write a little bit of code into our into the script tag that we have to basically just copy what we did right here to select the file that the user had selected in the input. So back at our script tag, I'm going to replace the debugger statement with the reference to the file that we just selected. So I'll say const file is document.querySelector. I'll select the input, then I'll look at the list of files, and I want to always just take the first file inside that list. So remember the bracket 0 right here is because .files, like so, it returns a file list object, which essentially behaves like an array. So if we want to select the first file in there, we'll say @0, like so. And there's the actual file object. Okay, so in this section, we made some progress by getting access to the file that the user had selected. Now I know that right now it might feel a little bit like we're kind of diverging off of Electron because we're really focused on JavaScript code that's being executed inside the browser. However, that really is a lot of what Electron is all about. With Electron, remember, we're still writing web applications. And so we're still spending a lot of time writing vanilla JavaScript code or React or Angular code. It just happens to be getting executed inside the context of an Electron application. So as we go throughout this course, yeah, we're going to focus on a lot of Electron related stuff, but we're also going to focus on a lot of web app related stuff as well. I've done my best to try to make sure that it at least seems a little bit interesting. And I always try to pull the emphasis or the focus back to the Electron side of things as well. Anyways, just a little quick aside there. Okay, so now that we've got some details about the file, let's take a quick break, and when we come back, we're going to figure out how we can use these file details to somehow read the duration of the actual video file. So let's take care of that in the next section.